Hello, good morning everyone. So I am B.V. Vamsakrishna, Assistant Professor of Department of Physics, AKNU, Rajahmundry. So we have completed the 2 units of EDC, which is Electronic Device and Circuit Theory. So now I am going to deal the Unit 1, the diodes, so in which the first topic is tunnel diode. So first of all, what is a tunnel diode? So tunnel diode is a heavily doped PN junction diode in which electric current decreases as voltage increases. So in what happens in the tunnel diode is when we increase the voltage, the electric current will decreases uh, after certain voltage up to the means every diode has some built-in potential, means threshold voltage. We call it as a threshold voltage. For silicon types of normal PN junction silicon diode, it has a 0.7 threshold or built-in potential. So every diode has some built-in potential. So if it is cross the voltage for the tunnel diode, if it cross the built-in voltage is crossed, then current will decreases, okay, while increases the voltage, external voltage. So you know the PN junction. P means P-type semiconductor, N is N-type semiconductor. So in P-type, the majority carriers are holes. In N-type, majority carriers are electrons. Remember that. In P-type, the majority carriers are holes. N-type, majority carriers are electrons. So I repeat, a tunnel diode is a heavily doped PN junction diode in which the electron means in which the electric current decreases as voltage increases. Okay, so every diode has some built-in potential or threshold voltage. So when it is exceed for the tunnel diode, the electric current will decreases. Okay. So what is tunneling? Tunneling is the means electrons are means penetrating from conduction band of N type to the valence band of the P type. That's the penetrating, means going from means conduction band of N type, it's going into the valence band of the P type. So tunnel diode is used as a very fast switching device in computers. Okay. So it is also used in high frequencies oscillators and amplifiers. So this is the circuit diagram of tunnel diode, which looks like this. So here anode implies that positive charge carriers, and negative means cathode is denotes the negative charge carriers. Means anode is a p-type semiconductor, cathode is a n-type semiconductor. Okay. So n-type semiconductor means, I already said the n-type semiconductor have the uh, can produce the more electrons, means there is abundant of electrons in the n-type semiconductor. So n-type semiconductor emits or produces electrons, so it is referred as a cathode. So cathode means here n-type semiconductor. So p-type semiconductor attracts the electrons which is coming from the n-type semiconductor. So electrons are means tunneling through this PN junction. The junction is called as a depletion layer. Okay. The p-type semiconductor attracts the electrons emitted from the n-type semiconductor. So p-type semiconductor refers as the anode. So p-type is referred as a positive one, and cathode is referred as a negative 1. Okay, negative charged plate. So let's see how the tunnel diode works. So let us consider the diode is not connected with external voltage, then we call it as unbiased tunnel diode. Unbiased means that there is no voltage connected to the diode. So when when any external voltage is not connected, this the, energy of the conduction band in n-type will equal to the energy of the valence band in the p-type, will coincide exactly. So when no voltage is applied to the tunnel diode, it is said to be an unbiased tunnel diode, which means these two energy levels, the energy level of conduction band in n-type will exactly equal to the energy level of valence band in the p-type, will exactly coincides. So there is no, so if you see that when unbiased tunnel diode, there is no current flowing through the conduction band to the valence band, because ఇప్పుడు మీరు ఒక if you imagine, if you analyze if you consider this phenomena has a water tank. So p-type has p-type, consider it is a p-type, there is a two water tanks, one is in more height, the another one is the less height. The water cannot flow from less height to the more height, higher heights. Okay, so what I'm trying to say is we have a water tank, one is at the table, one is on the table, the another water tank is on the floor. Okay, so now the water is cannot flow from the ground level to the certain height of the table. Okay, uh, likewise when no external current is supplied to the diode, so electrons cannot flow from the conduction band of the n-type to the valence band of the p-type. Okay, so in tunnel diode, the conduction band of n-type material overlaps with the valence band of the p-type material because heavily doped. Okay, so because of this overlapping, the conduction band of electrons at the n side and valence band holes at p side are nearly at the same energy level. So when temperature increases, the level of this, the conduction band energy level will slightly increases. There will be flow of electrons from the conduction band of n-type to the will enter into the p-type of to the p-type semiconductor. The same way that holes in the p-type will enter into the n-type semiconductor when temperature increases. So when temperature increases, some electrons tunnels from the conduction band of n region to the valence band of p region. In similar way, the holes tunnel from the valence band of p region to the conduction band of n region. Okay, so I already said to you, so when temperature increases, the conduction band energy level will slightly increases, so electrons will flow from the conduction band to the of n-type will go to the p-type or p-type region. Okay, when temperature is increases, we haven't connected any external source to the diode. Okay, so there will be small, if you see there will be a small current, that that current we call is a tunnel current, is passes through the N type to the P type semiconductor. Okay, so when small voltage is applied, so in step 2, if we connected the small voltage applied to the tunnel diode, what happens? Similar way in the has like when temperature is increased, the L means energy level of conduction band in N type will slightly increases. Okay, then the electrons will flow from N type to the N type region to the P type region. Okay, so there will be small tunnel current will generate across this PN junction diode. However, a small number of electrons in the conduction band of N region will tunnel to the empty states of valence of band in the P region. So this will create a small forward bias tunnel current. Thus the tunnel current start flowing with a small application of voltage. So what I'm trying to say is, if you apply the small voltage to the tunnel diode, okay, the energy level of conduction band will slightly increases. Okay, so when it is increases, there is a flow of electrons from the N region to the P type region. Okay, it will start moving. Okay, that there will be there will be generation of a small tunnel current. Okay, so this forward voltage is less than this the built-in voltage, threshold voltage, okay, of the tunnel diode. So when applied voltage slightly increased, what happens? Then what happens is, the energy levels means energy level of conduction band, energy level of N type will exactly means will matches the band of the N type P type energy valency band. Sorry, I repeat. So when the applied voltage slightly increases, what happen is, the conduction band will exactly equal to the valence band of the P type. There will be maximum electrons will flow. Then tunnel current will be increases. There will be maximum tunnel current will generate. Okay. So this is the thing, that because of the increase in the voltage, the overlapping of conduction band and valence band will increases. So the energy level of N side conduction band becomes exactly equal to the energy level of a P type valence band. As a result, maximum tunnel current flows. Okay, so in step 4, if we consider the applied voltage further increases, what happens is, when applied voltage further increases, the conduction band will slightly increases above the valence band of P type. So there will be decrease in the tunnel current, means there will be decrease in the flow of electrons from the N type to the P type region. Okay, that's the thing happens. So when voltage is increases, the tunnel current will decreases, electric current will decreases. So these things are happen below the built-in voltage or threshold voltage. Okay, if the applied voltage is further increased, a slight misalign of conduction band and valence band take place. So since the conduction band conduction band of n-type material and valence band of p-type material will still overlap. So this is the thing happening. So tunneling current will start decreasing. If applied voltage is largely increases, what happens is there will be uh, there will be no coincide between the energy levels of p type and n type. Okay, the conduction band of n type will not coinciding not at all coinciding with the valence band of p type. So there will be no flow of the charge carriers. Means charge carrier means there is no flow of electrons from the n type to the p type. So then means this voltage is more than the built-in voltage, then the forward current will means tunnel current will be zero. There will be no tunnel current. If applied voltage largely increases, the tunnel current drops to zero. So there will be a forward bias current. At this point, the conduction band and valence band no longer overlap, and tunnel diode operates in the same manner. So normal p-n junction diode, it operates in the same manner as the normal p-n junction diode. So if applied voltage is greater than the built-in potential of the depletion layer, the regular forward current starts flowing through the tunnel diode. The portion of the curve in which the current decreases as voltage increases is called as the negative resistance region of the tunnel diode. So we call this region is as a negative resistance region of the tunnel diode. So negative resistance region is the most important and widely used in characteristics of tunnel diode. So tunnel diode operating in a negative resistance region can be used as an amplifier or oscillator. Advantages and disadvantages of tunnel diode: long life, high speed operations. It is used in so it long last. The working of this tunnel diode will long last. The very high speed operation, low noise and low power consumption. Okay, the tunnel disadvantages is the tunnel diode cannot be fabricated in large numbers. The being a two terminal device, the input and output are not isolated from one another. Tunnel diode are used applications of tunnel diode. Tunnel diodes are used as logic memory storage devices. Tunnel diode are used in relaxation oscillator circuits. Tunnel diode is used as an ultra high speed switch. Tunnel diode are used in FM receiver. This is all about the tunnel diode. So next I will explain about photodiode and solar cell and Schottky diode in coming classes. Okay, thank you.